the Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month, and this is September 2025, and it's a great month. We have, of course, the autumnal equinox. Great things are happening in the sky that we're going to talk about, and we have a couple of special programs we want to talk about as well. So behind me is the Andromeda Galaxy. Maybe we could just bring that forward for a moment. And the Andromeda Galaxy is in all places, in the constellation of Andromeda. And I'm going to show you where to find that in the night sky, so you can actually see this galaxy with the unaided eye. Now, obviously, you can't see it like this. This is a Hubble Space Telescope view, but I'm going to show you where to find it. And obviously, if you have a telescope, bonus, even binoculars, bonus. So we're going to talk about understanding the night sky. And I thought it might be interesting to bring that up for you. Understanding the night sky, and you know me, I've been on the show for like decades, and the Sky This Month is what we're talking about. And I thought it'd be interesting for you to find out about some of the terminology that astronomers use that you hear from time to time, and you may be scratching your head, what does that mean? I want to explain those things to you. But first, a couple of important programs coming up. The first one you see on your screen, I know there's a lot of words there, so maybe you want to frame capture this or pause it on your DVR. But on September 20th, this year, obviously, from 10:30 to 4 at the McAuliffe-Shepard Discovery Center in Concord, New Hampshire, which is off of exit 15E. You can follow directions and such, but we have a great show program featuring Dottie Metcalf-Lindenburger, who's an astronaut, flew, and she is going to be there in person to bring the keynote, but there's going to be all kinds of STEM people there, STEM organizations, businesses. It's going to be great. We're going to debut a film, Asteroid Mission Extreme, which is our newest planetarium show, and then there's going to be a sale on memberships to the Discovery Center. So you don't want to miss that, and you can check out more detailed information at www.starhop.com and get the information about that. Now, something coming up early October, so I wanted to get it in on the September show so that you would be aware. So check this out. We have on Saturday night, October 4th, which, by the way, is the anniversary of the Sputnik launch in 1957. It's the day, though, the world changed forever, really. But the Belmont High School Astronomy Club is going to be hosting NASA's International Observe the Moon Night. And that will be, again, October 4th from 7 to 9 at Bryant Field in Belmont. And the zip there is 03220 if you're going to GPS it, 03220. And it's Bryant Field. We're going to have telescopes there of all sizes and types. There'll be some merch, swag, some things you can buy for really cheap, and some things given away for free. We're planning on our lunar scientist, Dr. Andrew Jordan from UNH fame, to be there. He operates is one of the operators for the Lunar Reconnaissance Orbiter, which is a satellite in orbit around the moon that is still in business. And he'll be on hand to show you stuff, talk about stuff, and you can ask him questions. And it's International Observe the Moon Night. Don't miss it, and you can check it out on the NASA website, International Observe the Moon Night, and look for Belmont, New Hampshire. There should be one of those little location signs that'll give you some more information. So very cool. Well, let's move on and talk about what is going on in the night sky and some of the vocabulary that you were coming to use. So, obviously in the sky there are constellations. And the two constellations that you see here are Sagittarius and Scorpio. And I chose these two because this is exactly where they are in relationship to each other in the night sky. And you can still see them early after the sun sets. But September, the first half of September is kind of your last chance for getting good views of the Scorpion and that. But constellations, they were the ancients put together these grouping of stars that to them meant something in their mythological stories and such. And they made maps, star maps. And other people got into the art of drawing these things. And what you see over on the right side is this Pegasus, Andromeda, and Pisces, the fishes. So star maps and charts were made that were depicting these various constellations. So I'm going to show you where to find these constellations, Pegasus, the square of Pegasus, and Andromeda a little later in the show. But notice that we've got these outlines here. And so just like cities and states and countries have boundaries, all the constellations have boundaries as well. There are 88 constellations in both the northern and southern hemisphere together. And in the course of a year in the northern hemisphere, well, at about 45 degrees latitude, plus or minus, we're at 43 degrees here in Concord, New Hampshire. And we get to see around 67 of the 88. So, you know, we're just missing like 20, 21 of the ones that you could see. So then you notice the star Alpheratz. And Alpheratz technically belongs to Andromeda, but we borrow Alpheratz to make this great square of Pegasus. And so this great square of Pegasus is what we call an asterism. It's a familiar shape made up of stars, in this case, that are from two different constellations. We borrow Alpheratz from Andromeda, and then 3 stars from Pegasus, and we make the square of Pegasus. And you can see that Andromeda comes up from the upper left as you look at it, from that star Alpheratz, which is at a magnitude 2. And I'm going to explain what magnitudes mean very shortly. So magnitude 2, fairly bright. The North Star, as I'll also mention again and show you where to find it, the North Star is also a magnitude 2 star, and I'll explain what that means. So constellations, they have boundaries. Andromeda and Pegasus, in September, you're going to be able to see it fairly early evening. I'm going to show you where to find those, which includes finding that galaxy, the Andromeda galaxy, which again is behind me. So we don't necessarily focus on all the bright stars, but the bright stars are helpful in making the shapes of whatever. Now, let's look at the Big Dipper, for example. Well, when you look at the sky, the ancients thought they were like plastered on what we would call the celestial sphere. They appear to be close to one another, but they're not really. This is just a projection effect, which it looks like they're up there on the celestial sphere. But they're very different distances from us. So you can see it points out where the nearest star is, which is the star Mizar here. And then we have this star here called Dubhe, and that's the furthest one away. And so they are just a line of sight. And just for your information, if you want to have a nice look at the Big Dipper and focus on that star Mizar, which is the nearest star to us, which is the middle star of the handle of the Big Dipper, you'll notice it's 2 stars, and you don't need binoculars to see that. You can see that with the unaided eye, but most people miss it because we don't take time to observe. So look at the middle star of the handle of the Big Dipper and see if you don't see there's a companion star there. And that star's name is Alcor, A-L-C-O-R. So now let's talk about the magnitude scale. It was first introduced by a Greek guy named Hipparchus, who lived 160 to 127 BC. And he got together with his buddies, and he, being a mathematician, liked to quantify things. So he said, hey guys, let's quantify the brightness of the stars. And of course, the Greeks are into the Olympics, started the Olympics. That's why the Greek flag, or the flag of Greece, is the first flag into the Olympic ceremonies, right? So he thought, hey, let's have the brightest stars be first magnitude stars, and then the second place stars will be second magnitude, third, fourth, fifth, and they decided to stop at 6. So the dimmest star possibly seen with the unaided eye would be a 6th place star, or 6th magnitude star. And so he talked about with his buddies and said, how much brighter do you think that first magnitude star, or those first magnitude, those first place stars, how much brighter do you think the first place stars are than the 6th place stars? And they chatted among themselves, and they came up with, we think that the brightest star is about 100, right? It's a good number to pull out of the air. The brightest star is about 100 times brighter than the dimmest star. So that makes sense. And so they set up that order of magnitude. First magnitude, the brightest. Ones you can just barely see is 6th magnitude stars. And when you do the math to figure this out, it's the 5th root, because there's 5 distances, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 is 5 intervals that you want to have the same multiplying factor, and from the first to the last is going to be 100. So it's the 5th root of 100, which is 2.512. So you can round that about 2.5 times is the difference between one magnitude and the next, the 5th root of 100. So the larger the magnitude, like 5 or 6, dim stars, because remember, like in a race, they're like in 4th, 5th, 6th place. And the smaller the number, like 1, 2, 3, those are like the first place stars, and they're the brighter ones. But now we got more modern equipment where we can quantify these things with photometers and instruments that can measure the brightness. And it turns out we need brighter than 1. We like the idea, they said, we like the idea of the 5th root of 100, and we like the idea of the faintest stars we see being 6th magnitude. So let's work our way up. 2.5 times brighter, 2.5 times brighter, et cetera, et cetera. And when we get to the brighter stars, like Sirius, the brightest star in the night sky in the either hemisphere, negative 1.42. Hipparchus had a stamp made after him. So here you see Sirius pointing to negative 1.42 for brightness. We have some bright stars that are out right now in September that are magnitude 0. And then, as I said, as you get to more negative numbers, things are even brighter. So check out the full moon, negative 12.5 for the full moon. The sun, negative 26.5 for the magnitude of the sun. And you can see the Hubble Space Telescope limit is down towards 30, and the James Webb Space Telescope is beyond that. Let's talk a little bit about the celestial sphere, and a couple of words to look out for here. When you look straight up, that's called the zenith. It's straight above you. The nadir is the point directly under you, which you can't see. It's like on the other side of the world. The celestial equator is a projection of Earth's equator on the night sky. So we do talk about the equator of the sky, and we would be talking about the celestial equator, which again is a projection of Earth's equator, that imaginary line projected up onto the sky, which goes right near the belt of Orion, for example, in the wintertime. And the North Celestial Pole is a projection of Earth's North Pole onto the CS, or the celestial sphere. So if you were at the North Pole, the North Star, the North Celestial Sphere would be directly above you, pretty close, within 3/4 of a degree. So these things move. And if you were to take like a photography shot, take your camera, open the shutter for, a time exposure, point it at the North Star, you're going to see that the constellations, and I just have the two here, that are actually asterisms, the Little Dipper and the Big Dipper, are going to move in a counterclockwise direction. But you'll notice that the North Celestial Pole, where the North Star is, named Polaris, isn't going to move much at all because it's over the northern rotational axis of Earth. And maybe you can notice here, if you follow my pointer, the two end stars of Ursa Major, Merak and Dubhe, or Merak and Dubhe, if you use those as pointer stars, they will point you to the North Star. So that's kind of cool, easy to find the North Star. So Ursa Major is the constellation. The Big Dipper is part of Ursa Major, the Big Bear, and the Little Dipper is part of Ursa Minor, the Little Bear. Now, the sun appears to move through these constellations, but we know it's Earth that is actually orbiting the sun in the course of pretty much a year, 365.25 days. So right now, we're over here. See, January is here. This is the path of Earth around, and we're over here. Now, July, we're into August. So you can see that we cannot see the constellations of like Leo, for example, because, Gemini, because it is in the pathway of the sun from where Earth is right here. But at night we can see Sagittarius, we can see Scorpio, right? We can see those constellations because they're on the opposite side of the sun. And so these constellations happen to be the constellations of the zodiac, and the sun goes through those constellations. So the sun appears to move through the zodiacal constellations. Another time we can talk about what goes in here. It's a constellation called Ophiuchus, which is the 13th member of the zodiac. And this path of the sun is called the ecliptic. The ecliptic is the projection of Earth's orbit on the celestial sphere. So here you can see this is the pathway of the sun through the sky, going through Aries, Taurus, Gemini, Cancer, Leo. That's called the ecliptic. Well, planets appear to be close to the ecliptic. Therefore, they're most always in a zodiacal constellation. Pluto is the furthest that can be off the ecliptic at 17 degrees inclination. Jupiter right now is in Gemini. Mars for September is in Virgo. Difficult to see, it's in the glare of the sun. Saturn is in Pisces, and Pluto is Aquarius. The planet Pluto is in Aquarius. Yes, it's a dwarf planet. It's in a new category, but it's still a planet. So let's talk about these two words, opposition versus conjunction. What do these words mean? These show up a lot in astronomy. The sun is in the middle of this diagram, and only Mercury and Venus can be an inferior conjunction, which means they can go between the sun and Earth. So when they are between the sun and Earth, only Venus and Mercury can do this. It's called inferior conjunction. If you have a planet on the opposite side of the sun, we call it superior conjunction. If a planet, which is all the outer planets, from Mars out to Pluto, are on the opposite side of the sun, we call it superior conjunction. So when a planet is in superior conjunction or inferior conjunction, we can't see it because of the glare of the sun. Now, when there's what we call a transit in inferior conjunction, only Mercury and Venus can do that, we can actually see the dots of the planets as black spots move across the face of the sun. A topic for another time. Then there's opposition, and opposition means that the planet is opposite the sun. So here's the sun, here's Earth, and here's the planet. In this case, looks like Mars is opposite the sun. And Saturn is going to be in opposition September 21st, 2025. So again, we see Earth here, the sun is on the left, Saturn is on the right, and we have this opposition. And this is going to be September 21st, and basically it's opposite the sun, so when the sun sets, Saturn rises. We have an equinox coming up. It's going to be on September 22nd at 2:19 Eastern Time, or Eastern Daylight Time, 2:19 Eastern Daylight Time. And that is when the sun crosses the equator. So if you lived on the equator, that's when the sun is going to be directly overhead for you. And then you have, in March, is the vernal equinox. But we're talking about the autumnal equinox, or the autumn equinox, September 20th. Now, the Stonehenge equinox is not really as significant as the solstices, the winter and summer solstices, when the rays of the sun come through the stones and cross what's called the heel stone. So equinoxes, there are still groups that do go to Stonehenge and have ceremonies for the equinox when the sun crosses the equator. And so this is a good day to get your eggs out and try to balance them on the end. September 7th is the corn moon. September 16th, I'm going to show you this in a little bit, exactly where to find it, but this is in the morning sky. Castor and Pollux are the twin stars. They're like the eyes of the twins. And on the morning of September 16th, Jupiter is in the area, and a waning crescent moon. This is just going to be a beautiful shot. The moon keeps moving, but Castor, Pollux, and Jupiter are going to be in the same relative position for some days, but the moon is always on the move. So if you want to catch this sight with the waning crescent moon, so to speak, in the midst of these other three, it's the morning of September 16th. So I hope you get a chance to enjoy that. Just to review, Aerospacefest at the McAuliffe-Shepard Discovery Center, September 20, and the suggested donation is $5 per person, and you get to see astronaut Dottie Metcalf-Lindenburger, and a host of other activities will be there. The Belmont Astronomy Club will be there. There'll be a variety of other STEM-oriented businesses with all kinds of neat high-tech equipment for everybody to enjoy. Plus, the premiere of our new planetarium show, which is Asteroid Mission Extreme. So don't miss that. That's Saturday, September 20th, September 20th, 2025 at the McAuliffe-Shepard Discovery Center. And then another reminder, Saturday night, October 4th, from 7 to 9, we have International Observe the Moon Night. And at Bryant Field, Belmont, New Hampshire, there'll be telescopes, merch, some to buy real cheap, some swag to give out, and lunar scientists there. So don't miss that. I just want to be sure, because some people tune in at the beginning of the show, the middle, the end, so I just want to be sure I cover all my audiences. Okay, so now we're going to take a look at the night sky, and I'm going to show you where to find some of these things that I just talked about. Well, I hope you enjoyed and learned something from some of those words and such. So now let me show you some of the things that we talked about. So I mentioned to you that on the early morning of September 16th, this is about 5:30 a.m. September 16th. Hopefully it'll be clear. But you're going to see the planet Venus close to the horizon. You can't miss it. We're talking a -4 for its magnitude. Then we have the two stars, which are around a magnitude 1. We have Castor and Pollux, which are the eyes of the twins. And then we have the planet Jupiter, which is at a magnitude about -2.5, so really bright. And in the area here, again, this is only going to be that morning of September 16th, the crescent moon is in the midst of Castor and Pollux and the planet Jupiter. So don't miss that morning. It should be good. The mornings before, after, you're still going to have Castor and Pollux and Jupiter and Venus, but this is the morning that the moon is going to be in the midst of them. Okay, so same day, middle of September, September 16th. Let's check out what is next. So here we are looking towards the east because we are looking for things to rise, and this is going to be in the vicinity of 9 o'clock, 8 o'clock actually in the evening. And so what I'm showing you here is that great square of Pegasus. You see the 4 stars, and over here this is the star Alpheratz, and Alpheratz is again borrowed to make the square of Pegasus, but it's at the top of the constellation of Andromeda, which goes along this way. And you may notice that Cassiopeia, that W shape, is in the picture as well. And this narrower angle, the acute angle, points to where the Andromeda galaxy is that you saw behind me earlier. So you can just make out a wispy spot with the unaided eye. Binoculars, definite help, and a telescope. The bigger, the better. Not necessarily the more power. It depends on the objective diameter, but you can have a nice view of the Andromeda galaxy. So let's put up the artwork, and you can kind of see what these things go to represent. So you can see here's Pegasus, the flying horse, and this is the great square of Pegasus here. And then this is Andromeda, which is over at this time in the evening, 8 o'clock or so in the evening, Pisces. Later on in the evening, everything that you see here in the east will be rising higher. Triangulum, the triangle, is near the horizon. And then we already mentioned that W shape is the queen, Cassiopeia. And that helps you also find the Andromeda galaxy. So, can you find them? Can you find the great square of Pegasus? You're looking east, 8 o'clock in the evening. Alpheratz, magnitude 2 star. And you have 2 diverging lines which make the constellation of Andromeda. Cassiopeia, the W shape, and the narrower angle will point towards that fuzzy spot, which is about halfway between Cassiopeia and Andromeda. So, worth getting out and enjoying the night sky. These are great fall constellations, and we begin fall, remember, September 22nd at 2:19 p.m. That's Eastern Daylight Time. Don't forget, on September 20th, we have Aerospacefest, and we have Dottie Metcalf-Lindenburger is going to be there. We have an opening of a new planetarium show, and that's September 20th, and it's just $5 suggested donation. And then don't forget about Saturday night, October 4th, International Observe the Moon Night at Bryant Field in Belmont, New Hampshire. There'll be telescopes, some merch, lunar scientists, and more. So we don't want you to miss the Saturday night, October 4th, International Observe the Moon Night. So I hope you enjoyed the show. There are plenty of things to get out and see in the night sky in the morning before the sun is up. Don't forget Aerospacefest, International Observe the Moon Night. And don't forget, if you have any questions, feel free to write to me, Dave McDonald, at astromannh@gmail.com. So I'm Dave McDonald for the Sky This Month. Keep looking up.